Our planet, from a distance, is a beautiful sphere of blue and white. This is the world we know, the familiar continents, and the shifting clouds. Yet, this familiar surface hides a realm far greater and more mysterious than anything we experience on land. Beneath the sunlit waves of our oceans lies a world of perpetual darkness, a place of immense pressure and profound cold. This is the deep sea, the largest single habitat on Earth, and it remains almost entirely unknown to us. It is a world shrouded in secrets, holding mysteries that we are only just beginning to comprehend. The stories hidden in this vast, dark expanse are perhaps the greatest untold tales of our planet. We have mapped the surface of the Moon and even Mars with greater detail than we have mapped our own ocean floor. A staggering majority of this underwater kingdom has never been seen by human eyes. It is a place where sunlight cannot reach, and where the rules of life as we know them on the surface are completely rewritten. Imagine a world where the only light comes not from the sun, but from the strange and beautiful glow of the creatures that live there. This is not science fiction. It is the reality for countless organisms thriving in the crushing blackness. Exploring this domain is like visiting another planet, one that lies right here on Earth, waiting patiently for its secrets to be unveiled. The sheer scale of this unexplored territory is difficult to grasp. It is a world that stretches for thousands of meters below the surface, a vertical landscape of canyons, mountains, and plains that dwarf any on land. For centuries, humanity looked to the stars and wondered what lay beyond our world, yet the greatest expanse of mystery was always right here, beneath the gentle lapping of the waves. The deep ocean is the final frontier on our own planet, a place that challenges our technology, our courage, and our understanding of life itself. Every journey into its depths brings back new questions and reveals wonders that we could never have imagined. As we stand on the shore and look out at the seemingly endless expanse of water, it is humbling to consider what lies beneath. The surface gives little clue to the drama and diversity unfolding in the darkness below. It is a silent, hidden world, but it is far from empty. It is teeming with life, with geological wonders, and with clues to the very origins of life on Earth. The pull to explore this unknown realm is irresistible, for in understanding the deep ocean, we come closer to understanding the full story of our planet and our place within it. The journey into this darkness is a journey into the heart of our own world's greatest mystery. When we look at a map of the world, we see vast land masses that we call continents. But this perspective can be misleading. In truth, we live on a water planet. The oceans cover more than 70% of Earth's surface, creating a single, continuous body of salt water that connects every continent. This immense volume of water is what makes our world unique in the solar system, a vibrant blue marble suspended in the blackness of space. It is the lifeblood of our planet, regulating our climate, shaping our weather, and providing the air we breathe. The sheer dominance of the ocean is a fundamental truth of our world, yet we often behave as if the land is all that matters. This great global ocean holds nearly all of the water on our planet, a staggering 97%. The freshwater in our rivers, lakes, and glaciers is just a tiny fraction in comparison. This saltwater world is not just wide, it is also incredibly deep. The average depth of the ocean is about 4,000 meters, or 2.5 miles. This creates a living space that is vastly larger than all the land-based habitats combined. If you were to take all the life on Earth, from the smallest insect to the largest elephant, and compare it to the amount of life in the sea, you would find that the ocean is home to the overwhelming majority. It is the true center of life on our planet. The diversity of life within this aquatic realm is simply breathtaking. From the microscopic plankton that form the base of the food chain to the blue whale, the largest animal that has ever lived, the ocean supports an incredible array of creatures. The sunlit upper layers are rich with vibrant coral reefs, schools of shimmering fish, and powerful predators like sharks and dolphins. But this is just a thin veneer of life on the surface. As we journey deeper into the zones where sunlight fades, we find a completely different cast of characters. Life here has adapted to conditions of extreme pressure and total darkness, resulting in forms that are both bizarre and beautiful. It is a humbling thought that this vast marine world, which governs so much of our planet's systems, remains largely a mystery. We have only explored a tiny fraction of it, perhaps less than 5%. The rest is an uncharted wilderness, a place of immense potential for discovery. Understanding this ocean world is not just a matter of scientific curiosity, it is essential for the future of our planet. The health of the ocean is directly linked to the health of all life on Earth, including our own. By turning our attention to this blue heart of our world, we can begin to appreciate its true importance and the urgent need to protect it. The ocean is not one uniform environment, it is layered, like a great aquatic building with many different floors. The top floor, bathed in sunlight, is known as the epipelagic zone, or the sunlight zone. This layer extends down to about 200 meters. Here, there is enough light for photosynthesis to occur, the process that plants use to create food. This zone is therefore filled with phytoplankton, tiny plant-like organisms that form the foundation of the entire marine food web. They are the meadows of the sea, providing sustenance for everything from tiny zooplankton to giant whales. This sun-drenched world is where we find the most familiar ocean life: dolphins, sea turtles, and colorful coral reefs. As we descend deeper, leaving the vibrant surface world behind, we enter a place of growing shadows. This is the mesopelagic zone, often called the twilight zone. It stretches from 200 meters down to about 1,000 meters. The light here is faint and ethereal, not strong enough to support photosynthesis, but just enough to create a dim, blue-gray world. The creatures that live here are adapted to this low-light environment. Many of them are masters of camouflage, with silvery or dark bodies that help them blend into the gloom. This is also where we begin to see the magic of bioluminescence, the ability of living things to create their own light. Life in the twilight zone is a constant dance of survival. During the day, many of its inhabitants remain in the relative safety of the darker depths. But as night falls on the surface, a great migration begins. Billions of creatures, from tiny shrimp to squid and fish, journey upwards into the richer surface waters to feed under the cover of darkness. This daily vertical migration is the largest movement of animals on Earth, a massive, silent procession that happens every single day, unseen by human eyes. It is a vital process that transfers energy from the surface down into the deep ocean, nourishing the life that waits below. The animals of the twilight zone have developed fascinating features to cope with their world. The barrelay fish, for example, has a transparent head and large, tubular eyes that can look straight up to spot the silhouettes of prey against the faint light from above. Other creatures, like the lanternfish, have patterns of light-producing organs on their bodies, which they may use to communicate, attract mates, or lure prey in the perpetual dusk. The twilight zone is a bridge between the familiar world of the sun and the utterly alien world of the deep, a realm of shadows and secrets where life puts on a spectacular, silent light show. Descending past 1,000 meters, we leave the last vestiges of sunlight behind and enter a world of absolute and eternal darkness. This is the bathypelagic zone, more commonly known as the midnight zone. It extends down to 4,000 meters, into a realm where the water is near freezing and the pressure is immense. Here, the only light is that which is produced by the animals themselves. Life becomes sparser, and the creatures that survive here are true marvels of adaptation. They have slow metabolisms to conserve energy in a world where food is scarce. Finding a meal is a rare event. So many have developed enormous mouths and expandable stomachs to make the most of any opportunity. The anglerfish is perhaps the most famous resident of the midnight zone. The female of the species has a fleshy lure that dangles in front of her mouth, tipped with a glowing ball of bioluminescent bacteria. In the total blackness, this small light acts as a bait, attracting curious smaller fish and crustaceans directly towards her waiting jaws. It is a wonderfully efficient and sinister method of hunting in a world without light. Other creatures here have developed large, highly sensitive eyes to detect the faintest glimmer of bioluminescence from potential prey or predators. The gulper eel, with its enormous, loosely hinged jaw, can swallow prey much larger than itself, a useful trick when meals are few and far between. Below the midnight zone lies an even deeper, more mysterious realm, the abyssopelagic zone, or the abyss. This layer stretches from 4,000 meters down to the ocean floor at around 6,000 meters. The name abyss comes from a Greek word meaning no bottom, which reflects how ancient cultures viewed this deep, dark world. The pressure here is crushing, hundreds of times greater than at the surface, and the temperature is just above freezing. For a long time, it was believed that no life could possibly exist under such extreme conditions. But expeditions have proven this wrong. The abyss is home to a surprising variety of life. The creatures of the abyss are often strange and ghostly. Many are colorless, lacking pigment that would be useless in a world without light. Some, like the tripod fish, have elongated fins that allow them to stand on the soft sediment of the ocean floor, waiting patiently for any scrap of food to drift down from the waters above. This marine snow, a continuous shower of dead organic material from the upper layers of the ocean, is the primary source of food for many abyssal creatures. Life in the abyss is slow, patient, and utterly dependent on the distant, sunlit world far above. It is a testament to the tenacity of life, which finds a way to thrive in even the most inhospitable corners of our planet. Even below the vast abyssal plains, the ocean floor is not flat. It is scarred by immense canyons known as oceanic trenches. These are the deepest parts of our world, plunging far deeper than the abyss. The most famous of these is the Mariana Trench in the western Pacific Ocean. It is a crescent-shaped scar in the Earth's crust, and at its deepest point, known as the Challenger Deep, the ocean floor lies nearly 11,000 meters, almost 7 miles, below the surface. If you were to place Mount Everest into the Challenger Deep, its summit would still be covered by more than a mile of water. This is the most remote and inaccessible place on our planet. The pressure at the bottom of the Mariana Trench is over 1,000 times greater than at the surface. It is equivalent to having 50 jumbo jets stacked on top of a person. The temperature is just a few degrees above freezing, and there is, of course, no sunlight at all. For these reasons, the trench was long considered to be a lifeless void. But in 1960, the submersible Trieste made a historic dive to the bottom, and its crew saw something astonishing: a flatfish swimming peacefully along the seafloor. This discovery proved that life could exist even under the most extreme pressure imaginable. Since then, further exploration with unmanned robotic vehicles has revealed a unique ecosystem. Another significant deep-sea location is the Puerto Rico Trench, located on the boundary between the Caribbean Sea and the Atlantic Ocean. It is the deepest point in the Atlantic, reaching a depth of over 8,000 meters at a point known as the Milwaukee Deep. This trench is particularly interesting to scientists because it is located in a geologically complex area where tectonic plates are moving. This activity can cause earthquakes and tsunamis, making the study of the trench important for understanding these natural hazards. Like the Mariana Trench, it is a place of extreme conditions, and exploring it presents enormous challenges for researchers and their equipment. These trenches are not just deep holes, they are active and dynamic environments. They are hotspots of geological activity and unique biodiversity. Scientists have discovered strange creatures like the Mariana snailfish, a small, pink, tadpole-like fish that thrives under the crushing pressure of the Challenger Deep. They have also found giant, single-celled organisms called xenophyophores, which feed on the sediment of the trench floor. These deep-sea trenches are like isolated islands of life, where evolution has taken a unique path. They are natural laboratories for studying how life can adapt to the most extreme conditions on Earth, offering clues about the potential for life on other planets. Exploring the deep ocean is one of the greatest technological challenges humanity has ever faced. The difficulties are immense, and they begin with the most fundamental force: pressure. As you descend, the weight of the water above increases relentlessly. For every 10 meters you go down, the pressure increases by 1 atmosphere, the same as the pressure we feel at sea level. At the bottom of the Mariana Trench, the pressure is over 1,000 atmospheres. This force is strong enough to crush most submarines as if they were empty drink cans. Building vehicles that can withstand such colossal forces requires incredibly strong materials, like thick titanium alloys and sophisticated engineering. Then there is the darkness. Sunlight penetrates only the very top layer of the ocean. Below 200 meters, the world begins to fade, and by 1,000 meters, it is completely black. This means that any exploration must bring its own source of light. Powerful lamps are needed to illuminate the surroundings, but even the strongest beams can only light up a small area at a time. It is like exploring a vast, unknown continent at night with only a small flashlight. This makes navigation difficult, and means that our view of the deep sea is always limited to small, tantalizing glimpses of a much larger, hidden world. The cold is another constant challenge. Below the surface layers, which are warmed by the sun, the deep ocean is a uniformly cold place. The temperature is typically only a few degrees above freezing, hovering around 2 to 4 degrees Celsius. This extreme cold can affect the performance of electronic equipment and poses a significant risk to any manned mission. The hulls of submersibles must be insulated not only to protect the occupants, but also to ensure that sensitive scientific instruments continue to function correctly. The combination of intense cold and crushing pressure creates an environment that is more hostile to machines and humans than the vacuum of space. Finally, there is the problem of communication and distance. Radio waves, which we use for communication in the air, do not travel well through water. This means that communication with deep-sea vehicles relies on sound waves, a much slower and less reliable method known as acoustic telemetry. Sending a command to a robotic vehicle on the ocean floor and receiving a response can take several seconds or even minutes. This time lag makes controlling the vehicles a slow and painstaking process. Overcoming these four great challenges, pressure, darkness, cold, and communication, is the key to unlocking the secrets that the deep ocean holds. The human desire to explore the deep sea is not new, but for centuries, we lacked the means to do so. Early attempts were limited to simple diving bells and rudimentary submarines that could only venture into the shallow coastal waters. The true era of deep-sea exploration began in the 20th century with the development of new technologies. One of the key breakthroughs was the bathysphere, a thick steel sphere lowered on a cable, which allowed naturalist William Beebe to make record-breaking dives in the 1930s. From within this cramped metal ball, he became the first person to observe deep-sea creatures in their natural habitat, describing a world of living light and strange, unknown fish. The next great leap forward came with the invention of the bathyscaphe, a free-moving submersible that was not tethered to a surface ship. The most famous of these was the Trieste, designed by Swiss physicist Auguste Piccard. In 1960, Auguste's son Jacques Piccard and U.S. Navy Lieutenant Don Walsh piloted the Trieste to the very bottom of the Challenger Deep in the Mariana Trench. This incredible journey to the deepest point on Earth was a monumental achievement, proving that humans could, with enough ingenuity and bravery, visit this incredibly hostile environment. Their observation of a fish at that depth changed our understanding of life on Earth forever. In more recent decades, the focus of deep-sea exploration has shifted towards remotely operated vehicles and autonomous underwater vehicles. These robotic explorers can go deeper, stay down for longer, and operate in conditions too dangerous for humans. The ROV Jason, for example, has been instrumental in discovering and studying hydrothermal vents, while vehicles like Sentry can map vast areas of the ocean floor in high detail. These robots are our eyes and hands in the deep, equipped with high-definition cameras, powerful lights, and robotic arms that can collect samples of rock, water, and even living creatures for study back on the surface. One of the most significant discoveries made by these robotic explorers was the existence of hydrothermal vents. In 1977, near the Galapagos Islands, scientists found cracks in the ocean floor spewing out superheated, mineral-rich water. Around these black smokers, they found a thriving ecosystem of bizarre creatures, including giant tube worms and blind white crabs. This was a revolutionary discovery because this entire community was based not on sunlight, but on chemical energy from the Earth's interior, a process called chemosynthesis. This proved that life could exist in complete darkness, independent of the sun, a finding that has profound implications for the search for life elsewhere in the universe. The discoveries at hydrothermal vents were just the beginning of our understanding of how life can thrive in the most unlikely of places. The giant tube worms found there have no mouth and no digestive system. Instead, they have a special organ filled with bacteria. These bacteria take the toxic chemicals from the vent water, such as hydrogen sulfide, and convert them into energy for the worm. This symbiotic relationship is a perfect example of how life adapts in creative ways to survive in extreme environments. It shows that the building blocks of life are not just sunlight and water, but also the raw chemical energy that comes from deep within our planet. The deep sea is full of such wonders of adaptation. The vampire squid, which lives in the oxygen minimum zone, is not a true squid. When threatened, it doesn't squirt ink, but instead pulls its webbed arms over its body like a cloak, revealing rows of fleshy spines. It can also release a cloud of glowing mucus to distract predators. Another fascinating creature is the zombie worm, or Osedax, which lives on the skeletons of dead whales that have fallen to the ocean floor. These worms have no stomach. They secrete an acid to dissolve the bone and have bacteria that help them digest the nutrients within, anchoring themselves with a root-like structure. These discoveries force us to reconsider the very definition of life and where it might be found. If life can thrive on chemicals from volcanic vents in the crushing darkness of our own oceans, could it not also exist in similar environments elsewhere? The icy moons of Jupiter and Saturn, such as Europa and Enceladus, are thought to have liquid water oceans beneath their frozen surfaces. It is possible that these subsurface oceans could also have hydrothermal vents, providing the energy needed for life to begin and evolve, completely independent of sunlight. The deep sea, therefore, serves as a model for what we might one day find in the outer reaches of our solar system. The deep ocean remains Earth's greatest reservoir of mysteries. With every dive, we find new species, new geological formations, and new insights into how our planet works. Exploring this realm is crucial, not just to satisfy our curiosity, but to understand the full extent of biodiversity on Earth and the processes that regulate our global climate. The deep sea is a library of natural history, holding the secrets of our planet's past and perhaps the key to our future. As we continue to develop the technology to venture deeper and stay longer, we can be sure that the ocean's darkest secrets will yield wonders that will continue to astonish and inspire us for generations to come.